Welcome to episode number 3. We're going to talk about resistance today. We've already learned about volts and amps. We looked at voltage, which is the pressure. We looked at current, which is the flow. And the third thing we're going to look at is going to be resistance. So when we talk about fluid flow and we talk about the resistance, it could be something as simple as a smaller tubing compared to a larger tubing, which is more restricted or has more resistance. We could talk about something being pinched back, like a valve barely being open. It has a restriction or resistance to it compared to being all the way open or a lot less restriction or resistance. We could also just have an orifice in line with a smaller hole in it that actually stops some of the flow, or actually restricts some of the flow, should I say. So if we had an orifice in line, it would actually resist or restrict the flow. So I could actually take something as simple as some small vice grips and pinch the line off. And it's a lot harder. I'm pushing about as hard as I can. And it's getting through. It's not enough flow to make the flow meter actually move, but it's all I can do to get the fluid to push by this pinched off tubing. And that's very similar to how it works with electrical resistance. The higher the resistance, of course, open being, or infinity being the greatest resistance. And then we can have what we know as a resistor that has a known resistance. This one in particular is red, violet. It looks purple, but they call it violet. So we got red, violet, black, and silver. And man, this day and time, it's so nice to get just electronics app or electrical app that actually has symbols and actually has the color bands. There are different band resistors. I still keep with me in my kit of resistors. I have a little sheet that I had got from Radio Shack Resistors, or resistors I have ordered. It just has the little cheat sheet with until you memorize it, the black, brown, red, orange, yellow, green, blue, violet, gray, white. So until you remember those 0 through 9 color code, you can just keep this with you, keep it handy. But I just say again, those apps these days are just so nice to be able to pull up your smartphone and just pull up the app and just go through and select your bands. Because there are different band resistors, and not really for the subject today, but even surface mount devices, SMD, those small resistors, it takes a little getting used to. Some of the codes are straightforward, some are a little different. So it helps with that as well, looking those up. But for this resistor, we have a red, violet, black, and silver. And if we look on here, red's going to be 2, violet's going to be 7, and black on the third band means times 1. So it's just simply 27 ohms. And how will we measure that to make sure it was good? Well, we just bring our meter over on our common and our volt ohm diode jack for the red, and we have it on ohms. So we put this across. We're looking for around 27 ohms. It's actually 28 ohms, it's very close. Of course, we have a little bit of lead resistance, and also the fourth color band, which is silver, means that we're 10% in tolerance. So we allowed about 2.7 ohms either way. So we take this 27 ohms. I'm going to put it in line with my electrical circuit just to simulate the flow actually being restricted. So I have an orange jumper, I have a blue jumper. So now if I just put these together, I just simply have the resistance of the leads, and it runs real similar to it did earlier in the previous video. But I'm going to take my 27 ohm resistor, which is fairly low ohms for this circuit anyway. And you see that there's no problem. You don't really notice much of a voltage drop across it. As far as the fan turning, it still turns quite well for this circuit. So for this circuit, that's a lower resistance. Now this is a brown, black, black, gold. So it is a 100 ohm. A 100 ohm resistor. There we go, 99.8. As we check it with our meter. Let's put it in the circuit and see if 100 ohms makes much of a difference. We saw a lot slower startup on that one, and it is running slower. We have cut back the flow a lot as we're dropping across this greater resistance, even though it's only 100 ohms. But now we have a orange, white, orange, gold, which is a 39 and 3 zeros, or times 1,000. So it's 39,000 ohms. The gold being a 5% tolerance. So there we go, we're reading a little less than 42K. If we put it across now, we're getting on up pretty high resistance, so we're not moving enough current at all to make the fan move. Besides regular resistors, we also have some potentiometers. This one in particular is it says 10 or 103, so it's 10 and 3, so it's 10,000. So this is a 10K, 0 to 10K potentiometer. Just meaning that it's variable resistance, so it is 0 to 10K depending on where you turn the dial to. So now with resistance, we learned how to measure it. We saw it affect somewhat in the circuit. We also want to talk about how is resistance measured. You heard me say ohm. We usually refer to resistance in ohms, which is, we always refer to it with a symbol of the Greek letter omega. This is actually the capital omega. So if we talk about something 10 ohms, we'd usually write it 10 in the Greek letter omega. We also typically use R for resistance when we're talking about it in a circuit. It's not uncommon at all to see on a circuit board resistors, if you can see that on here, like that's resistor R21, for example. It's not that unusual to see a R and a number beside a resistor on a board. So now that we have learned a little bit about resistance and how it resists the flow of electrons, and we've learned how it's similar to pinching the hose or having an orifice that restricts the flow, we learned that the higher the value of resistance, whether it be a resistor or any other circuit resistance, we learned that the higher the value, the less flow, the less electrons flow in that circuit. We've learned that we use and represent it by R, and it is in ohms. which is represented by the Greek letter omega. So now we have learned that volts is V, that current is I, and resistance is R. In the next episode, we're going to learn about Ohm's law and why all this is important. So things are going to pick up a little bit from this point as we learn their relationship, how to calculate it, and why it matters. So I hope you learned a little bit about resistance in this episode. If you liked the episode, please give it a thumbs up. Please subscribe. Thanks for watching.